Hello students, in my earlier videos I have already discussed what are enzymes, how are they different from non-biological catalysts, what are the rules of nomenclature, and in this video I am going to tell you about the classification of enzymes. The Enzyme Commission has recommended 6 classes of enzymes. Each class is then divided into subclasses, and the subclasses are further divided into subclasses. This helps developing a code number for the enzyme. So I repeat once again that every enzyme has got an EC number, in which the first number will indicate the enzyme's class, the second number its subclass, the third number its subclass, and eventually you will come to know what is the fourth digit. Now, each enzyme code number is prefixed by EC. So, this is the EC, which is the prefix, and it contains 4 elements separated by points with the following meaning. The first number, that is 1, it shows to which class the enzyme belongs. There are 6 main classes of enzymes: oxidoreductases, transferases, hydrolases, lyases, isomerases, and ligases. Remember, they have been allotted specific numbers. So, number 1 is allotted to oxidoreductases, number 2 to transferases, number 3 to hydrolases, number 4 to lyases, number 5 to isomerases, and number 6 to ligases. Now, the second number. The second number indicates the subclass within the class. It tells which chemical group the enzyme is acting upon. Now, among the subclasses, there are various subclasses, whether it is acting on CHOH group or aldehyde group or the CH group, whatever. Then the third number, this green colored number, the third number is the subclass. It usually refers to the nature of the acceptor group. And the fourth number, this 27, is the serial number of the enzyme in the subclass. Now, this is the EC 1.1.1.27. Here, the first number 1 indicates the first of the 6 classes. As I've already told you, class 1, that means the number 1 is allotted to the class of oxidoreductases. So, this means the enzyme belongs to first class oxidoreductase. The second number 1 indicates the first subclass, that is the enzyme that acts on CHOH group. There are a number of other subclasses in this class. For example, 1.2 is for aldehyde group of donors, 1.3 is for CH group of donors, 1.4 is for CH-NH2 group of donors, so on and so forth. Then the third number 1. The third number 1 indicates the subclass, that is the enzyme uses NAD as acceptor. So in the oxidoreductases, there are number of such acceptors. For example, the hydrogen acceptor may be 1.1.1 NAD or NADP, 1.1.2 for cytochrome, 1.1.3 maybe molecular oxygen, so on and so forth. And the fourth number 27 indicates that the enzyme is at the 27th position in the list of enzymes in the subclass. Now finally we come to the naming of the enzyme. The systematic name of the enzyme is L-lactate NAD oxidoreductase. According to the guidelines of the Enzyme Commission, the class 1, that is oxidoreductase enzymes, are to be named as donor acceptor oxidoreductase. So here the donor is L-lactate. So this is L-lactate. The acceptor is NAD+. So here this is NAD and it is separated by a colon. So donor is L-lactate. This is the colon and the acceptor is NAD. And finally the class of the enzyme oxidoreductase. The common name or the trivial name of the enzyme is lactate dehydrogenase. And the systematic name of the enzyme is L-lactate NAD oxidoreductase. This equation clearly shows that the enzyme is an oxidizing or reducing enzyme, and it oxidizes L-lactic acid or lactate by removing hydrogen, which is accepted by NAD+, and finally it gives the pyruvate. Thank you.